Hi, my name is Sai Pritam Minakota. I am currently working on a Capstone project for a company called Parlay. So this is a company which helps financial institutions to assess and approve small business loans. So for this company, generate we're trying to create a loan intelligence system which uses a machine learning model to check the eligibility and fit of a particular applicant and finalize whether they should be approved for a loan or not. So I'll dive straight into the process. This is our team, and I don't want to dive deep into the specifics of the team members. And so I'll dive straight into the project. So we are creating an AML drive loan summarization system. This is basically what the process is, how it works. So the applicants who are applying for the small business loans, they send all their data to the company, and there are different types of eligibility criteria for each type of lenders, based on which Parlay tries to generate a, a description whether the applicant is fit or not based on the scores they get from the scoring system that they currently have. And based on this scoring system, they check if the applicant is fit or no. And after that, this future scope is basically uh, Parlay giving the applicant feedback on why if why they are not approved or why they are approved, which factors in their application is useful and which factors in the application led them to their decline. So the scoring system that the Parlay uses right now is this. For example, you can see different points awarded to different types of uh, loans, sorry, different types of applicant profiles. For example, if the applicant profile's industry is preferred, then they give 3 points to it. The most important score or parameter, I think, is the personal or character credit score. So basically, how the scoring system works is it takes all these parameters as inputs, and the details from the applicant's profile will have all these details. For example, if a person name is Joe and his credit score is 766. So this detail will be entered into the variable or the formula that they have to access a particular profile, and it will basically calculate the total points of that applicant. Then this is the total scores for which the label that they provide as excellent, good, caution, and decline. If it's excellent, then it's auto approved. If it's decline, then it's auto decline. But if it goes to if it's either good or caution, then there's actually a person sitting there in Parlay who tries to uh, manually check if the person is a good fit or a bad fit for the person for that particular lender. So we are trying to automate this mechanism by using a machine learning model, which also doesn't require this individual authority for deciding whether an applicant is fit or not. So this is the problem that they have. It's not particular problem. It's like an equation, and it's a total architecture. And we are going to work on this. I mean, our team one from this Parlay is going to work on this. So what multiple single label classification model means is there are different labels. Like for example, here right now we have 7A type of loan, Express, and 504. These three types of loans are the total labels that we have, and we need to check each applicant profile for three different types of loans. And this type of approach, multiple single label classification model type of approach, uses multiple models for each label and then concatenate all the results and give a certain feedback to the applicant whether on which types of loans the applicant is eligible for or not. So that is the approach that we are going in. Team two has a different type of approach. So the first part of our project is to understand the project, the terminology, and everything. And then based on the terminology and based on the synthetic data that Parlay provided us with, it has like 50 to 100 rows and description for each column name. regarding what this column name is, what DSER is, what NAICS is. And based on that, we need to generate lots and lots of synthetic data to train our model. So we try to generate 20,000 rows, and on those 20,000 rows, uh, we divided them equally. So each type of loan has 20,000 rows, and these are all the columns that are very important for the synthetic loan generation. And before we go further, what we try to do is we actually had some ideas about using XGBoost or using random forest. So we tried all these types of models. Uh, yeah, we tried all these types of models beforehand, before data cleaning or data preparation. So, but each and every type of model gave us almost 100% accuracy. So we thought it was completely overfitting, it was not working. So we tried to clean or prepare the data. So we tried to prepare different versions of data for testing. So first of all, for testing, we declined small business loans with low scores. And here's the result for that. Even when we decline low scores for the applicants, for example, decline low scores means that we automatically decline every applicant who has low scores. But this didn't change much. We got 100% for everything, even if we did this. Then the next type is randomly decline 25%. This is basically faking the results. In this, what we did is we converted 25% of yeses to nos. Then this basically helps the model because the model tries to memorize the data, the formula behind the data. And even if you go through like a million rows, after the first 10,000, 20,000 rows, it basically gets hold of the data because this is a synthetic data. And it gets 100% accuracy even if you provide million rows. But declining 25%, declining few yeses to nos, says that the formula that the model memorized is wrong, and the model needs to actually learn from the data instead of memorizing it. So for 504 loan type, we had another problem, like 17,000 out of 100,000 samples. We tried to generate more data for 504. 17,000 out of 100,000 samples have eligibility. So there's a huge imbalance, class imbalance in it. So we tried two different methods called undersampling and oversampling. So undersampling and oversampling results are here. And what is the summary of undersampling and oversampling performances? Oversampling improved the performance, increasing bias towards majority class. So models like random forest classifier and XGBoost, XGBoost, they both improved in oversampling when compared to others. For example, Naive Bayes has declined a lot in its performance, and Random Forest and MLP, they also had a very high increase in performance because in undersampling, what not, Random Forest and MLP tend to do better when there is a huge data set. So they rely on uh, la they basically rely on large data sets. So I think oversampling gave us very good insights and worked very well. So this is where we are right now. This is our results till now. This is where we reached after working for like 3 or 4 weeks. So hopefully we get some new data, historical data that we can work on. Even if it's very less historical data, I think they're going to provide us like 7,000 rows. Even if it's 7,000 rows, we can create synthetic data based on the 7,000 rows, which will be more accurate than the synthetic data that we have generated till now. So I think that would be very much helpful in creating the model. And after creating the model, our future scope is to create a pipeline where the data is automatically pushed into the system into the loan intelligence system once they apply in the portal, and it assesses the eligibility and then gives a result and a feedback. So this is a total part that we're working on, and this is where we have reached till now. Thank you.